Srileka, Department of Chemistry. Now I am going to explain on the topics of this electrode potential. Here I am going to speak about the what is an origin of the electrode, electricity, and differentiate between this current and electrode potentials and the important terminologies which have been used in this electrochemistry is that is what is a conductor and what is a non-conductor. The metals which can accept an electric current is called as a conductor, and the materials which does not conduct an electric current is called as a non-conductor materials. And the next one is a capacitor. The capacitance which expect the electrons is known as an electrons, and this from this current, electrode, electricity, what is an electrolytic solution, and this terminologies which have affect the electrode potentials, that is a metal M which is that consists of a metal ions Mn plus with valence electron. When the metal M is placed in a solution of its own salt and any one of the following reactions will occur. And first one is the positive metal ions may passes into the solutions, that is M gives Mn plus Ne plus oxidation, and the positive metal ions from the solution may deposit over the metal, that is Mn plus Ne minus gives M reductions. Here I have shown that the examples 1, zinc electrode dipped in zinc sulfate solution. When zinc electrode is dipped in zinc sulfate solution, Zn goes into the solution as Zn2 plus ions due to oxidations, and Zn gives Zn2 plus 2E minus. And the zinc electrode attains a negative charge due to the accumulation of valence electron on the metal. The negative changes developed on the electrode attracts the positive ion solutions. Due to this attraction, the positive ions remains close to this metal. When the copper electrode dipped in copper sulfate solution and the copper electrode is dipped in copper sulfate solution, Cu2 plus ions from the solutions deposit over the metal due to this reductions. Here the Cu2 plus gives Cu2 plus 2E minus. When the copper electrode attains a positive charge due to the accumulation of Cu2 plus ions, the metal positive charge developed on the electrode attracts a negative ion from the solution. Due to this attraction, the negative ions remains close to this metal and then changes to the reverse process. When the zinc electrode in zinc sulfate solution, thus a layer of positive or negative ions is formed all around the metal. This layer is called Helmholtz electrical double layer. This layer prevents the passing of the positive ions from or to the metal. A difference of potential is consequently set up between the metal and the solutions. At equilibrium, the potential difference between constant value, which is known as an electrode potential of a metal. Whenever the metal electrodes will deposit in the zinc with the zinc sulfate solution and copper with copper sulfate solution, the metal deposit over the zinc and it removes the negative ions due to this attraction. And when copper, the electrodes will remains in the again copper metal due to the attraction of the metal. Here the layer which can forms by using this potassium sulfate by using this reductions, and the oxidation potential which is had if oxidation occurs at the electrode at equilibrium, the potential of the electrode is oxidation potential. The tendency of the electrode to lose electron is oxidation potential, and the reduction potential which has the same. The tendency of an electrode to gain electrons is called reduction potential. And this third one is the single electrode potential. Whenever it has a measure of tendency of a metallic electrode to lose or gain electrodes when it is in contact with the solution of own salt. And the standard electrode potential E is the tendency of a metallic electrode to lose or gain electrons when it is in the contact with a solution of its own salt with 1 molar concentration at 25 degrees Celsius. This is the process how this electrode plating can be done. Thank you.